So in this problem, we need to calculate the moment of inertia of the pendulum with respect to z-axis passing through O. So let's read the problem statement. The pendulum consists of a 4 kilogram circular plate and a 2 kilogram slender rod. Determine the radius of gyration of the pendulum about an axis perpendicular to the page and passing through O. So let's assume that this plane of paper is xy axis. Okay, so let's say this is x and this is y. And z axis, as you know, as per the right hand rule, is perpendicular to the plane and it's coming out from the plane. So this is z axis. Okay, so this tip of the pen is positive z axis. So this is the example of composite rigid bodies. So the pendulum has two parts, slender rod and circular plate, and they both are rigid bodies. So in order to calculate the radius of gyration, we first need to calculate the moment of inertia of the pendulum with respect to O. Now the formula sheet that has been provided to you has the formula only for the moment of inertia for the axis that passes through the center of mass. For example, for the slender rod, the center of mass is here. So G is the center of mass for, let's call it G1, that is center of mass for slender rod, and G2 is center of mass for the circular disc. So the formula gives us moment of inertia only for the axis that passes through the center of mass. However, we have studied parallel axis theorem. So once we calculate the moment of inertia for axis that goes through G1, then we can apply the parallel axis theorem and then calculate the moment of inertia for the axis that passes through O. So we will do that same for both the slender rod and circular plate separately, and at the end we will add the moment of inertia of slender rod with the moment of inertia of circular plate to get the total moment of inertia of the pendulum with respect to O. And once we have that equation, once we have that value of moment of inertia, using the equation for radius of gyration, we can calculate K. Okay, so let's start. So for plate, Ig, there is moment of inertia for the P for plate with respect to its center of mass is 1/2 mr square. So when you substitute the value of mass of the plate here, which is 2 kilogram, which is 4 kilogram, and the radius of the plate, which is 1/2 meter, and then you get the moment of inertia of plate with respect to its center of mass, that is G2, for the axis passes through G2, is 0.5 kg meter square. Now the moment of inertia with respect to axis that goes through O, that is the center of rotation, for the circular plate, we need to apply the parallel axis theorem. So it's IGP plus MD square, where IGP is 0.5 that we already have calculated, M is mass of the plate, which is 4 kilogram, and D in this case is the distance between the two axes. So distance between mass center of the circular plate and point O, and that distance is 2 meters plus 0.5 meters, so that is 2.5 meters. So this is 0.5 plus 4 into 2.5 square. So this is 25.5 kilogram meter square. Okay, so this is the moment of inertia of only the circular plate with respect to O. Next, we need to do the similar thing for thin slender rod. So for rod, its moment of inertia Ig for rod is 1 by 12 ml square, where L is the length of the rod. So when you substitute the mass and length of the rod only, this number is 0.66 kilogram meter square. And then moment of inertia of rod with respect to O using parallel axis theorem is this point. 0.66 is moment of inertia if the rod is to be rotated with respect to G1. But in this example, the rod is rotated with respect to O. So we have to apply parallel axis theorem. Okay, and this number, in this case, D is the distance between G1 and O, that is 1 meter. So this is 0.66 plus 2 kilogram multiplied by 1 square. So this is 2.66 kilogram meter square. And then the total moment of inertia for the rod is the combination of moment of inertia of the basically the algebraic addition of 25.5 with 2.66. So I'll call this I total. So I total is equal to IOP plus IOR. Okay, and then you add these two numbers, you get the answer as 28.16 kilogram meter square. So this is the moment of inertia of the entire pendulum if when it is being rotated with respect to point O. And in this example, we need to calculate radius of gyration. So for radius of gyration, we know the equation I0 is, for example, I is the moment of inertia is equal to mk square. So radius of gyration k is I divided by m. But here it is the mass of the total pendulum, right? Because we are using the total moment of inertia, so we need to use the total mass. Okay. So in this equation, so this is square root of 28.16 divided by 4 plus 2, that is 6 kilogram, and this number is 2.16 meters. That is the radius of gyration k for the pendulum, and that finishes the problem. Problem 2. Determine the moment of inertia about an axis perpendicular to the page and passing through the pin at O. The thin plate has a hole in its center. Its thickness is 50 millimeter and the material has a density of 50 kg per meter cube. So in this example also, xy axis is this plane of paper and z axis is perpendicular to the plane of paper. We need to calculate the moment of inertia of square plate with a hole at the center when it's being rotated about point O. So we apply the similar approach that we have applied in the previous problem, that this is the composite rigid body where we have two different shapes, square and circular hole. So what we need to do here is we need to calculate the moment of inertia of square, and then we need to subtract the moment of inertia of thin cylinder. We can replace this circular hole by a thin circular plate. So the square minus circular plate, that is the total moment of inertia of the entire rigid body with respect to its mass center, which is here. And then we apply the parallel axis theorem and calculate the moment of inertia with respect to O. So that's very similar to previous problem. The only one extra step that we need to do here is we haven't been given the mass of the plate. Okay, so but we know the density and we know the size of the plate from the dimensions. So we can calculate the mass by multiplying volume with the density. So let's start from there. And this number is in millimeter, all other values are in meter. So we need to convert this millimeter value into meter. So first step is, what is the mass of the square plate only without the circular hole? So mass, I will call this ms, where s stands for square. So mass of the square plate is its volume multiplied by density. So the volume of the plate is nothing but its length, width and thickness. So it's multiplication of 1.4 meters with 1.4 meters with 0.05 meters. So it's 1.4 multiplied by 1.4 multiplied by 0.05. This is the volume. So length, width and thickness multiplied by its density, which is 50. And this is 4.9 kilograms. So that is the mass of the square plate. Now for mass of this whole, as I said, we can replace it by circular plate. So mass of the circle, that's why it's C, is its volume multiplied by density. The volume of circular plate is nothing but its area multiplied by thickness, okay, multiplied by density. So area of circular plate is pi r square multiplied by thickness multiplied by density. So let's substitute this number. So this is pi, radius is 0.15 square, thickness is 0.05. So this whole thing is just the volume of the circle multiplied by density, and that gives us weight of the circular plate, which is 0.176 kilogram. So this is the weight of only square, this is the weight of only the circle. So the total weight of the plate is nothing but weight of square minus weight of circle, because circle has to be subtracted from the square as it is the whole, and that number, sorry, this is the minus sign here, and that number is 4.723 kilograms. Okay. We also need, at some point we need the distance from the center of mass of the square plate with respect to point O. So we need this distance here. Let's call this distance D. Okay, and we can calculate it using the angle, which is 45 degree, because this is square plate. So the total angle is 90 degree, half of that is 45 degrees, and we know the length of this side is 1.5 meters, sorry, 1.4 meters. So this height D is 1.4 sine 45. That is this height, because this angle is 45 degrees. So this is somewhere here. And then when I take the sine angle, we basically project this along the y-axis. Okay, and then that distance between 2 points from here to here is 1.4 sine 45. So let's finish this part here. So 1.4 times sine 45, and that number is 1.060 meters. Okay, so we have done all the preparation now, and we are ready to calculate the moment of inertia. So moment of inertia, okay, let me move this so you can see it. So moment of inertia of the entire plate with respect to its center of mass, Ig, that is with respect to this point G, is 1 by 12 mass of square, and it's a square plus b square, minus 1/2 mass of circle or circular plate into r square. So we need to subtract because this is the algebraic addition, so we need to subtract the mass of thin circular plate from the square plate. So this is the equation for moment of inertia of square plate with respect to its center minus moment of inertia of circle with respect to its center of mass. Okay. And then when you substitute all these numbers here, that is 1 by 12, this mass is 4.9, a square plus b square is 1.4 square plus 1.4 square minus 1 by 2, this is for circle, so its mass is here 0.176, and its radius is 15, so it's 0.15 square. And when you solve this equation, you'll get this moment of inertia is 1.59 kilogram multiplied by meter square. That is the moment of inertia of this entire plate if it is being rotated with respect to g. But then the plate is not rotated with respect to g, it is being rotated with respect to O. So we need to apply parallel axis theorem. Okay. So in that case, I with respect to O is Ig plus md square, where this is total mass, so this is mass of the plate. Okay. And okay. So this is 1.59 plus mass of the plate is 4.723 multiplied by d square is this distance that we have calculated, 1.016, 06 square, and then you solve this and you get the final answer as 6.23. This is 6.23 kilogram meter square IO.